Hello everybody, welcome back to Calculus 3. This is the solutions video for section 3. All right, let's get the first question. It says find the following for the vectors u and v. So we have to find dot product, the magnitude, and the cosine of the angles. Yeah, for this one, I'm going to use paper. All right. So 12(3), number 1. U is 8i 3j plus radical 5k. V is negative 8i plus 3j minus radical 5k. First one, we have to find the dot product, v dot u. Remember the dot product is simply the sum of the corresponding components. So the first one is going to be 8, or negative 8 times 8, 3 times negative 3, negative radical 5, radical 5. So negative 64 minus 9, radical 5 is simply 5. So the v dot u is negative 7378, negative 78. So that's our first answer, negative 78. Now the next one's asking for magnitude of v. So it's negative 8 squared, 3 squared, negative radical 5 squared. Negative 8 squared. 8 squared is 64. 3 squared is 9. Radical 5 squared is 5. 73 plus 8 is radical 78. Since u and v have the same coefficients, just different signs, it doesn't matter because we square them, it's going to be the same. 8 squared, negative 3 squared. It's going to give us 64 plus 9 plus 5, which is the same values. It's radical 78. So these are both radical 78. Now it says find the cosine of the angle from v to u, or between v and u. Cosine of the angle between v and u. All that's really looking for is the cosine value is u dot v, magnitude of u, magnitude of v. Remember, the formula we started dealing with first is u dot v is equal to so we're trying to find the cosine of the angle. So divide both sides by magnitude and we get this. We're going from v to u. That's important because if we went from u to v, it'd be a different sign. So the magnitude of v to u is negative 78. radical 78 times radical 78. Radical makes it 78. The answer is -1. So that's the cosine of the angle between there. -1. No, now we're looking for the scalar component of u in the direction of v. It's just now a scalar. No, that's the projection of u to v. Okay. The scalar component of u in the direction of v is since one from u, that's radical 78. The cosine is -1. So the answer is that's the scalar component. Now we got to find the projection of v onto u. Or u onto v, I mean. Formula is that. U dot v is -78. Magnitude of v is radical 78 squared. And the vector v is -8i plus 3j minus radical 5k. That's from the given part, the original part. Radical 78 squared is simply 78. So the coefficient is -1. So just change all the signs. So the projection of u onto v is +8i minus 3j. So we have 8, -3, radical 5. All right, given the vectors v and u, answer A through D below. All right. All right, let me write this one down. This is 12.3, number 2. I'm saying that v is equal to 6i 3j minus 2k (7i plus 24j). Question A says find the dot product between v and u. The dot product is commutative because it's going to give us 2 vectors and give us a scalar solution. Remember, it's going to be 6 times 7. The j's are 3 times 24. And the k is -2 and 0. 42 plus 7.2 plus 0. So the v dot u magnitude of v, which is 6 squared, 3 squared, negative 2 squared. 36 plus 9 plus 4. 36 plus 4 is 40, so it's 49. Square root of 49 is 7. Magnitude of u. 7 squared plus 24 squared. (24 squared) is 576. Square root of 625 is 25. So those are the magnitudes. That's what A asked for. So it's 114, 7, and 25. Now find the cosine of the angle between u and v, or v and u. The cosine of the angle is dot v, which 114, 7 times 25. Which 175. So that's the cosine of the angle from point A to point B, or u to v. So that is now see, find the scalar component of u in the direction of v. Yeah, of u in the direction of v. That formula is u dot v over magnitude of v. So it's 114 over 7. And D says find the vector projection of u onto v. That's u dot v, magnitude of v times v. Well, this we got from up here. Times vector v is 6i plus 3j plus 2k. Distribute those. We get 684 over 7i, 342 over 7j, and there's our projection. Put into terms, so it's 684 over 7i, 342 over 7j, minus 2. All right, so that is that page. Question 3. Given the vectors v and u, answers A through D below. It's the same thing we just did, actually. Oh well, so let's see this. V is 4i minus 2k, I plus j plus k. U dot b. 1 times 4. 1 times, since there's no j's, it's 0. 1 times -2. So u dot v is 2. Magnitude of v, 4 squared plus 0 squared plus -2 squared. 16 plus 0 plus 4 is radical 20, and that simplifies. Plus 20 is 4 times 5. And the magnitude of u, since they're all coefficients of 1, so 2 radical 5, radical 3. B is asking for the cosine of the angle from V and U. The cosine is U dot V, magnitude of U, magnitude of V. So it's 2 radical 5. The 2's cancel, so it's 1 over radical 15. And the scalar component, U dot V over the magnitude of V. U dot V is 2. Magnitude of V is 2 radical 5. Yeah, if you wanted to rationalize it, you could have done that. Multiply top and bottom by radical 5. But this is good enough. It'll go into the computer. Find the vector projection. Which is U dot V over V squared times V. It's radical 20, so I'm gonna square it and get rid of it. 4i plus minus 2k. Squared cancels, so it's 1 over 10. I distribute. So my final answer is 2 over 5i, 1 over 5k. Now, find the angle between vectors u and v. And now we're looking specifically for the angle of the vector between the vectors. Section 3. This is question number 4. So find the angle between u and v. U is equal to negative 2i minus 3j. V is equal to 4i minus 3j minus 6k. Since we're looking for the theta, we'll take the inverse cosine of u dot v, magnitude of u, magnitude of v. So we got to find, so we have to find u dot v. So first, u dot v. The u's, negative 2 times 4, 3 times negative 3, 0, negative 6. So it's negative 8 plus negative 9 plus 0, negative 17. Oh, they're both negative. They're both negative. So it's negative 8, so it's positive 1. It's negative 3, negative 3. So it's a positive 9. Then the magnitude of u, negative 2 squared, negative 3 squared. 4 plus 9 is radical 13. Four squared, negative 3 squared, negative 6 squared. 16 plus 9 plus 36. 52 square root of 61. Okay, so I have all the pieces. The inverse of cosine u dot v is 1. Radical 13 times radical 61. I put that in the calculator. In radians is 1.59. what's radians? Do the same thing with the next one. U is radical 5 I minus 6 J. V is radical 5 I plus J minus 2K. So we have to find these first. So U dot V radical 5 times radical 5 negative 6 times 0, 0, negative 2. Oh, no, that's 1. Negative 6 times 1. Radical 5 is 5. Negative 6 times 1 is negative 6. 0. So it's negative 1. Now the magnitude. So it's radical 5 squared, negative 6 squared. 5 plus 36, square root of 41. Radical 5 squared, 1 squared, negative 2 squared. 5 plus 1 plus 4. Radical 10. Okay, so now we got to put them all together and solve for the theta. I continued. So theta equals the inverse of cosine of negative 1, radical 41, radical 10 is negative 1, radical 410, which is 1.62. See the questions. It's 1.62. Next one. A gun with a muzzle velocity of 1220 is fired at an angle of 24 degrees above the horizontal. Find the horizontal and vertical components of the velocity. So the force of this is the muzzle velocity is 1220. So the magnitude of the force is 1220. Theta equals 24 degrees. So we're looking for find the horizontal components of the velocity. Magnitude of the force times cosine theta, the magnitude of the force times sine theta, the horizontal and vertical. 1220 cosine of 24 degrees. 1220 sine of 24. $1,114.5, 496 0.2. Doesn't want any decimals. So round this one up, round this one down. So that's the velocity, the horizontal and vertical velocities of that gun. So the horizontal component is 1,115, and the vertical is 496 feet per second. And the last one here. Show that the vector AI bj is perpendicular to the line ax plus by equals c by establishing that the slopes of the vector v is a negative reciprocal of the slope of the given line. Well, first let's look at the equation. This is linear equation, solve for y. Negative ax plus c divided by b. So y is equal to negative a over b plus c over b. The slope of the line is negative a over b. By definition, the slope of a vector is the negative reciprocal. So since it's negative reciprocal, it's b over a. Yeah, so then they're perpendicular. So the slope of the vector is negative of the slope. No, slope of the vector is reciprocal. No, is equal. The slope of the vector is negative reciprocal of the slope of the line by definition. Right. That does it for that section.